Good morning, calculus. All right, so guys, the plan for today is we are going to do a really quick introduction video to particle motion. So the first thing I want to do is I want to review some quick relationships, S of t, V of t, and A of t. Remember that S of t is the position function. So the position function tells me, hey, where am I with respect to time? So this is my position function. V of t tells me via velocity. It tells me how fast am I going, velocity. How fast am I going with respect to time? And A of t is my acceleration. Oh no, why am I having acceleration? All right, and A of t is my acceleration here. So remember that in order to go from position to velocity, I am going to take the derivative of position. In order to go from velocity to acceleration, I'm going to take the derivative of velocity, or I could take the second derivative of position. And so that's the relationships that are going on here. And we're going to go ahead and talk more about them today in this thing called particle motion. First thing, position. If the graph is increasing, okay, so we're going to write some colors here. If my graph is increasing, I say that my object is moving forward. If my graph is decreasing, we can say that the object is moving backwards. And if the graph is neither increasing nor decreasing, we can say that the object is straight up not moving. For velocity, if the velocity is positive, so if my velocity function is above the x-axis, we say that the velocity or the object is moving forward. If the velocity is negative, if my velocity function is below the x-axis, we say the object is moving backwards. And if the velocity is equal to 0, the object is not moving at all. So let me just kind of show you what I'm talking about graphically. So for this first one, if I have a position graph, we'll call this graph S of t. This graph S of t. All right, so let me just real quick graph this. If this is the S of t function, and let me just kind of graph something that is good for everyone. We'll do a sine function like this. Okay, when the function is increasing, so let me go ahead and highlight that. If the function is increasing, that means it has a positive slope. I know that the function is, the object is moving forward. And if the function is decreasing, if it has a negative slope, the object is moving backwards. When it has neither an increasing nor decreasing slope, right here and right here, we say the object is not moving at all. In fact, we can see right there that that is a max or min, and that is where the derivative is equal to 0. All right, let's move on to the velocity graph. If I have a velocity graph here, we'll call it V of t, and I'm going to draw the same kind of graph. This one is different. It's not the same. It's S of t. It's V of t. This is saying, hey, what's my velocity with respect to time? If my velocity is positive, so if this is saying, hey, if I'm above the x-axis, then I know my object is moving forward. In essence, if my slope is positive, I'm moving forward. So if the slope is, or the velocity function is above the x-axis, I'm moving forward. Just like in S of t, when I'm increasing is the same thing as positive slope. Secondly, if I have a negative velocity, so if my velocity is below the x-axis, it's less than 0, I'm moving backwards. That makes sense because in the position function, if my position is decreasing, if it has a negative slope means I'm moving backwards. So if velocity is less than 0, I am moving backwards. All right, last question here. Speeding up versus slowing down. If I have a positive slope, and I'm increasing, so what this is saying here is if I'm increasing at the same time that my velocity function is increasing, then I say that I am speeding up. So let me show you what I'm talking about here. Let me actually delete this, and we're going to do a whole new graph here. All right, so this question right here is completely referring to a velocity graph. So I'm actually going to label it. I should have done that before. So this is for V of t. So if I have V of t, and we'll say V of t looks something like this. If I am positive, so if I'm above the x-axis and increasing, so let me go ahead and just highlight for a minute. All right, if I'm above the x-axis, that's here and here, and I need to be increasing. So I'm only increasing, let's see, I only have a positive slope here and here. So the places where I have both red highlighter and that red marker, that is where I'm speeding up. So red highlighter, red marker, I'm speeding up. If I'm positive and decreasing, so if I'm positive, I have a red highlighter, blue marker. So if I have a red highlighter, blue marker, I'm positive, but I'm decreasing. That means that my velocity, I'm slowing down. That means that I might still be increasing. I might still have a positive slope, but it's getting less positive every second that I'm moving along. So if I have a positive slope, if I'm above the x-axis and I'm decreasing, that's going to be the same thing as me saying, hey, I have red highlighter, I have red highlighter, blue marker. Now, if I'm negative, that means I have blue highlighter. So blue highlighter is going to be below the x-axis, negative. Let me kind of make that clear here. There we go, increasing and decreasing. Okay, there we go. That might be a little bit easier. All right, so if I have blue highlighter, so that means I'm below the x-axis and I'm increasing. All right, let's go ahead and see, where am I increasing? Where do I have a positive slope? I have a positive slope here and a positive slope here. So where I am increasing and I have a blue highlighter, I would say that I'm slowing down. So I'm slowing down where I have blue highlighter, which means I'm negative, and I am increasing. I know it doesn't sound quite as intuitive, but it does kind of make sense that if I have a negative slope and I'm increasing, I'm actually getting less and less negative as I go. And so that one right there, let's get a blue marker, a red marker. That is going to be slowing down. Last one, if I'm negative and decreasing. So if I'm negative and decreasing, that means that not only do I have a negative slope, my slope is getting more and more negative as I go. It's getting bigger and bigger and bigger, farther and farther away from zero. So if I am negative and I am decreasing, I have a negative slope on my velocity graph, then you can say that I am actually speeding up. And the reason we say speeding up, if I think about velocity, velocity doesn't really have a sign attached to it. Velocity could be negative, it could be positive. It's not the same thing as speed. And so velocity is basically like direction speed. It's like speed with like a direction on it. So in this case, if I have a negative slope on my velocity and I'm below the x-axis, it actually means that my function is going to be speeding up. My particle is going to be getting faster and faster and faster. It's just going to be moving left instead of right. I say left and right. Backward and forward are also interchangeable with left and right. All right, let's go ahead and practice at least one problem. All right, so since an object is moving along a line, the following graph gives the object's position relative to its starting point. For each point on the graph, is the object moving forward, backward, or neither? All right, biggest thing here. This is going to be the biggest factor on success and non-success. This is a position function. This is the position function. So remember that this is me just saying, hey, where am I with respect to time? So on the graph, is the object moving forward, backwards, or neither? Well, if I go back to my information here, if I have a position function, if I want to know about forward, backward, or neither for position, I need to know about increasing or decreasing. So basically increasing means, hey, positive slope, and decreasing means negative slope. So what I'm looking for is positive and negative slopes. Let me get my highlighters out. All right, so at this first point here, it looks to me like I'm just going to go through. I have negative slope, negative slope. Let me get a highlighter. Negative slope, negative slope, negative slope, negative slope, negative slope. And the rest is going to be positive slope. Positive. Oops, that's actually positive. Positive and negative. All right, so the question is, for this first point here, we're going to, I'll just kind of call it A. We're going to call this first point here A. All right, does it have a negative or a positive slope? Well, looking at it, it has a negative slope, so I can say that point A is moving backwards. It's moving backwards, and in some cases, you might say it's moving left. Left and backwards are about the same. All right, next one, B. All right, so B, it looks like it's decreasing, but it's also kind of increasing at the same time. It's actually at a minimum here. And so we can say that its slope is actually 0. If its slope is 0, then it's neither moving backwards or forwards. And so we can see that that is going to be neither. All right, let's try point C. Point C has a positive slope, and so I can say it's moving forwards, and another interchangeable word for forwards would be it's moving right. All right, last one here, D. We can see once again that that is on a maximum value, so its slope is equal to 0. And so this one is a neither. All right, let's move on to the next couple of questions. An object is moving along a line. The following graph gives the object's velocity over time. So remember, this one here is different. This is v of t. This is velocity. Is the object speeding up, slowing down, or neither? Well, let me get my highlighter out for a minute. I'm going to first highlight where it's above the x-axis and then highlight where it's below. After that, with my marker, I'm going to mark up, hey, when is it increasing, when is it decreasing? Well, it's increasing here, and it is decreasing the rest of the time. Okay. All right, let's go ahead and talk about each point. Let's go ahead and talk about each point. So this point here, we'll call this A. We'll call this point A. This will be B, C, and D. So for point A, I am above the x-axis, and I am increasing. So that's a red on red. That is going to be equivalent to me speeding up. So that one is speeding up. Let's talk about point B. Well, point B is neither increasing nor decreasing. In fact, it actually happens on a cusp. And so we can actually say neither to this one. This one is neither. It's neither increasing nor decreasing. All right, point C. It is above the x-axis, and it is decreasing. So think if it's above and decreasing, those are two, like think about above as being positive, decreasing as negative. Positive times a negative is a negative, and so this is actually slowing down. We can check that using our chart here. If I'm going above the x-axis, I'm above the x-axis and I'm negative, so that's right here. It's positive and decreasing. I'm slowing down. So this one right here, we're going to say slowing down. Last one, letter D. Well, I'm below the x-axis, blue, and I'm decreasing, which is also blue. A negative times a negative is a positive, and so this is actually speeding up. All right, last one here. This one is still velocity graph. This is still v of t. It says for each point on the graph, is the object moving forward, backwards, or neither? Because this is not the same as speeding up or slowing down. If I'm moving forward, let's go back to our graph here. If on a velocity graph, I'm moving forward when my velocity is positive and I'm moving backwards when it's negative. So really all I'm looking for here in forward and backwards is when is my velocity positive, when is it negative? Well, it's positive above the x-axis here, and it's negative below the x-axis here. And so let's go ahead and answer these quickly. So A, B, C, and D. All right, so A is going to be moving forward. We could also say it's moving right, and that's because it's above the x-axis. For B, I would say it's moving backwards because it's below the x-axis. It's also code word for left. Letter C, I'm going to say neither because it's on the x-axis. It's neither moving up or down. It's neither above nor below. And so it is going to be neither. In essence, what it is that it's the derivative equaling 0. And remember, when derivatives equal 0, I have a chance of having a min or max. That's where those happen. All right, last one, point D. That is above the x-axis. If it's above the x-axis, it has a positive slope on v of t, which means it's moving forward, which is also code word for moving right, which you might see on like a web sign. All right, that's as far as we're going to get today. Sorry for maybe rambling on about this. But basically, just expect to have these types of questions. I'm going to assign a Khan Academy that have similar questions like these, and that is pretty much it for today. If you have any questions, feel free to send me an email or a reminder.